All right, on page 533, this is number 15, where we are supposed to find a list of partial sums, finite sums of 2 terms, 3, 4, 5, 4 and 5 terms, and then we're going to approximate what the actual sum is of this, and then we'll confirm it using the formula to find the sum of an infinite geometric series. So this is an infinite series, and it appears to be geometric. So we just want to start with the sum of the first term is just 3/4. The sum of the first 2 terms is 3/4 minus 3/8. So 6/8 minus 3/8. So 3/4 minus 3/8, which is 3/8. Okay, and we can see that, well, we'll talk about that later. So then the sum of the first 3 terms plus 3/16. If we put this all in sixteenths, we have 12/16 minus 6/16 plus 3/16. We get 9/16. So we're looking 3/4, we go down to 3/8, up to 9/16. We're going to swing back and forth, you know, and start to narrow in on one value here. The sum of the first 4 is the sum of all the prior ones plus the extra term. So when you get these all in a common denominator over 32, it's 15 over 32. And dare I say, it looks like it's getting pretty close to 16 over 32, pretty close to 1/2. So if we go all the way and do the sum of the first 5 terms, the 5th term would have a 3 in the numerator. It would be positive, and this would be 64, because you see how the denominators are doubling. So plus that 3/64, and if you put these all over a common denominator, or just take this and add the 3/64 to it, you get 33/64 again. Notice this was a little less than 1/2, this was a little more than 1/2, the next one will be a little less than 1/2, and we're gradually going to hone in on 1/2. So we think that the sum, the infinite sum, is 1/2. Okay, so then when we actually go to find it using the formula, we need the first term is 3/4, and the common ratio is negative 1/2, as we see with the denominators doubling, and it's alternating positive to negative. So the infinite sum is 3/4 divided by 1 minus negative 1/2. So that's 3/4 divided by 1 plus 3/2, or 1 1/2, which is 3/2. So this is 3/4 divided by 3/2 is multiplying by 2/3, and so we get 2/4, we get 1/2, which confirms our suspicion. So that's number 15. This is a geometric series. It's infinite. It converges to the sum of 1/2.